Okay, it says we're recording. All right, so what questions do you guys have?
So I just want to go over like exactly when to know if it's a t-test versus a z-test, because it's easy to figure that out on the homework because like we were learning about that thing that week, so we just used that formula. But I
I
just want to
know,
make sure that I actually have it down
and
before.
that makes the question really hard. Now, you know what we were going to do last time is I have a list of scenarios. I think I might, believe it or not, I cut out a chapter or two this semester. So let me see if I can pull that up. I usually give a quiz on how do you pick the right test, but let me see if I can find it here. I have this thing, and I just call them scenarios. There's actually usually not enough information to actually solve the question, but there is enough information to here. There is enough information to pick out whether it's a T or a Z. It's not where I thought it was, though. Oh, no, I cannot find it. Oh. Okay, I think I found it, and hopefully hopefully this is a good one. Okay, let me start sharing. These will just be practice. And we'll try to go through these fairly quickly so that we can go through a bunch of them. All right, music industry is trying to understand the effect that downloading music has had on music revenue. Before Napster, when music was often pirated, do you guys even remember Napster? Do you remember Napster, Allie? Oh, you are so young. Wes remembers it, though.
Yes, I'm that old, thanks.
Okay, you're not that young. All right. Napster used to be a big deal. People would just steal music. They'd get music for free. Now you got Apple Music, and it's great. But anyway, people used to just get free music. That was even better. Anyway, and then the music industry sued Napster and put them out of business, so that's why you've never heard of them. But national rating for pre-Napster was 44.9, with a standard deviation of 9.8. In post-Napster area, they discovered that less music was being purchased at traditional music stores, but that the concert ticket prices were skyrocketing. And relatively cheap downloads were popular. After applying the rating system to post-Napster, they've calculated an annual rating and want to compare it to the pre-Napster data. Which hypothesis test should they use? Okay. So as we do this, I think usually the instructions I say are identify the numbers. Is it categorical or quantitative? Which equation would you use? What are the alternative hypotheses? Now, I just want to remind you, there's not enough information to actually do the problem, but there is enough information where you should be able to answer these 4 questions. So, I'll let anybody take off where they want to go.
Your mu is 44.9, and your sigma is a 9.8.
So mu equals 44.9, sigma equals 9.8.
This is quantitative, and that would mean that the test you need to use is a t-test, correct?
Wouldn't you use a z-test since we know sigma, but we don't know s?
No.
I don't know.
Okay. So let's see, you pulled out all the music. Yeah, we don't know what our n is or anything, do we? So that's all we got. So mu and sigma, which equation should you use? Okay, we're going to vote. So especially since we have a thing. Now, so remind me again, Wes, your choice was what?
I said T just because it was it'd be a one mean quantitative.
Okay, and Easton went with z-test mean. Okay, so does anybody want to guess any other ones? We're just going with those two. Okay. How many people do we have here, by the way? Is it just 4 of us? I thought there was more than that. So it's 5. How come I can only see 4 people, but 5 people voted? That's weird. Who am I not seeing? Oh, Allie, that's right, because you're on camera. I'm not used to looking at you at the bottom. All right, so we got 5 of you. All right, so it looks like 4-1 Z, and that is the correct answer. It's a 1 test Z. So why? We'll let Easton, since you picked the right answer first. Z1 mean. Z-test mean. And it's because why again, Easton?
Because we identified the numbers as mu and sigma.
Yes, sigma. Sigma is the difference there. If that had been S, an old S, then it would have been a T. Does that make sense?
Question: with this specific problem, what wording would we have to change for it to be a t-test? I just want to see the comparison.
If they had taken this out, if that was all you knew, that would now be a t-test. Or if they had said that the sample standard deviation was that.
So if they would have given you like a sample mean and the sample standard deviation along with the mu, would it have worked? If they would have given you an X bar and an S?
Well, you would need so if I take out the standard deviation completely there, you would have to have a sample mean and a sample standard deviation in order to do it.
Gotcha.
So, and we don't have those numbers, so we can't complete it. But you would absolutely have to have those. Now, one thing I always like to tell people, you had better always have your sample standard deviation because you collected the data. Now it's a little different in a problem like this because you're basing it on somebody else's scenario, but yeah. So, all right, null and the alternative hypothesis. Who wants to do that?
So your null hypothesis would be mu is equal to 44.9. And sorry, I'm trying to figure out what the alternate is. I want to say its mu is not equal to 44.9.
Okay, just so that Allie doesn't think that we only do this to her, we're going to say, do you agree or disagree with Easton? Okay, we're unanimous. All right, Easton, you must be right. Okay, should we do another one? Is this helpful, by the way, Allie and Wes?
Yes.
Okay, let's see if I can fit all this on one page. Excuse me. All right. Carlino is the quality manager at a medical equipment manufacturer. He's currently involved in a project which requires about 8 feet of plastic tubing for each dialysis machine manufactured. Excuse me. Purity of the tubing is important and standards are tough to match. The current tubing supplier has a failure rate of about 12%, and Carlino has found an alternate supplier that he thinks has the potential to have a lower failure rate. He is able to sample 74 sections of tubing out of their manufacturing line over a period of 6 weeks. He sends the samples out for testing, and even though the tester is able to report the results with an accuracy of 200 parts per million, Carlino only cares if the impurity is less than 750 parts per million, which is suitable for the dialysis machine, or over, which is a fail. Once the data are collected, which hypothesis test should Carlino use? Now the problem is, here is what I'm going to do. I'm going to erase this, and then it'll fit on the page, I think. So let's answer those same 4 questions. And now it's got to be somebody who didn't answer has to answer it this time. So Wes and Easton are off the hook, it sounds like.
So it's S equals 74, right?
S equals 74. So you're saying, no, remind me what S means.
It's the O. Okay, never mind. I take that back.
You took it back.
Yeah, because isn't S the sample standard deviation? So that's the 74 is just a sample size.
So do you want to change your S to another letter?
Yes.
Okay. What are you changing it to?
I don't know. Do you change it to sigma?
What does sigma mean?
Oh no, that means the same dang thing. Never mind. No, I take that back again. I don't know. I'm just going to be quiet now.
All right, who can fill it in?
So if it's not if it's the sample size, then it would be X bar.
X bar. Was that a head nod, Easton? Or a head shake? I don't know. A nod means shake. Yes, a shake means a no, right?
Yes, it was a head shake.
It was a head shake. I'm gonna head shake on that one too. I won't put it up to a vote. This one's a hard one. I heard a hum, and usually that means Seth was going to say something. What were you going to say, Seth?
I was gonna make sure X bar is the mean, right? Not mean. Yeah, mean, right?
Which mean?
The mean of a population.
It's not the mean. X bar is not the mean of a population.
Sorry, I just can't remember what X bar is. You just brought it up. But I was going to go with her first one, S, because it's a sample, and I don't know, either my thoughts are either S or N.
S or N?
I'm not sure 100%.
Sounds like a vote. Must be voting time. Okay, here we're going to do, okay, so we're talking about something equals 74, and Seth has given us two choices, so, Wes has already voted even before I could put my thing on here. S, and yes. Has everybody voted? I think everybody's voted. We got 5 people here, I think. Yes, it is N. N is your sample size. Oh, except for Janie's here. Do we have more than, oh, Janie, there you are. Okay. So we got 3 at the bottom, 3 at the top, so that's 6 people. Okay, good. Okay, so N is 74. That was the easy one, which wasn't so easy, it looks like. What other numbers do we have in there that are useful? We'll open it up to everybody because I don't want to take too long. But Elise, it must be your turn to pick some number.
So we have mean, which is 750.
76, is that what you said?
750.
What's 76?
750.
Oh, 750.
Yes. Mean, that's a mu.
Which, that's a mu? You're saying that's mu?
Yes.
Ali, do you agree with that one? Or should we do a vote?
I don't think I agree with it because there's like a percentage, so I'm thinking that's going to be a Z proportion thing, but I'm not sure which numbers go where.
Okay, what do you think, Ali? Because you noticed a percent here. I'm going to leave that there for now. We'll erase it if we think it's not useful later.
Well, because there's a percentage, I would say that P would be 0.12 because it's not P hat, because P hat would be something divided by something. So that's all I got at the moment.
Okay, so if we've got a P equals 0.12, do we want a mu equals anything?
No.
No. So that's correct. This one's, so that was very astute observation by Ali. The 12% very key. Now let's look closer at these things here. Now, actually, it has a failure rate of 12%. And normally we would probably call that Q, right? Q is 0.12 and P would be what?
0.88.
0.88. Because P is usually probably a probability of success, whereas Q is probability of failure. Now, if you wanted to call a failure a success and a success a failure, I guess you could do it the other way, but I'd probably go with that one. Okay. So now we're looking at, well, let's go to this question. Is this categorical or quantitative?
Categorical.
It's categorical. And they've told us that this is suitable and non-suitable. So that 750 parts per million is actually, we've turned that into a category rather than a mean. So this one was tricky, as Run DMC would say, right? Does that make sense at least?
Yes.
Yeah.
If they don't know who Napster or what Napster is, I don't know that they're going to know who Run DMC is either.
Do you guys know? Okay, we're going to do a poll. Quick question. Do you know? Have you heard of Run DMC? Yes. No. Oh, Allie, you are much too young for me. Seth. Oh my gosh. You guys need to go watch the video Walk This Way with Run DMC. They got Aerosmith too. It's a great video. So only Wes is old enough to know this. This is terrible, you guys. Holy cow. I don't think they're that old.
And it's making me feel really old.
I know. All right. Okay, back to this. Okay. But that's your homework assignment, is to go find the YouTube video with Run DMC. Okay? They were the first cool rap group, just so you know. All right. Which equation should you use now that you've got all that stuff? Oh, before we do that, who haven't I picked on? Janie, I'm going to pick on you. What's your alpha?
0.05.
Okay, good. Thank you. Just wanted to make sure. Because why?
Because it's not mentioned. So when it's not mentioned, we always assume it's 0.05.
Perfect. See, and I told you I would forget to put it in, and I definitely did on these. All right, so I'll open it up for anyone except for Allie and Wes and Easton. Which equation do you use?
We use the chi-square test because it's categorical.
Okay. So Jane's going with chi-square. Agree? Disagree? Everybody's disagreeing with you. We haven't even taught you the chi-square test. I wouldn't be that mean to put it on.
See, I was stressing about that one. I was even being tested on it.
That's next
Wow.
week. That'll
No
be on
wonder
the
I couldn't
final
find
next week,
anything
but
on
it's
it.
not here yet. Yeah, we haven't learned that one yet.
Wow. Okay. See what I get for being confident in myself?
Yeah, there will be no chi-square test on this test, okay? So what's your second choice, Janie?
Z test?
Which Z test? We've got more than one.
Oh. Oh, what was it called? It's when we have P. Isn't it like Z proportion or something like that?
Okay, should we do that one again? Agree, disagree. Who hasn't voted? Seth didn't vote. And Janie, I guess you agree with yourself. All right, what happened to Seth? How come Seth's not voting? There we go, thank you. All right, you're right on that one. And what's the null and the alternative hypothesis? I'll let anybody answer this one.
So would your null hypothesis be Q is equal to 0.12? And then your alternate would be Q is less than 0.12.
Let's see here. Yeah, because he thinks it's less failure rate, right?
Mm-hmm. I mean, there's no point in changing to the new one if it has a higher failure rate.
Yeah.
And you could also write that as P equals 0.88 and P is P is greater than 0.88, right?
I was just going to ask that question. Great minds think alike. So we could go with either way, right? Because normally we don't do Qs, right? So you said P equals 0.888. P equals P greater than 0.88. So this is funny because the way that Easton did it, it would be a left-tailed test, but the way that West did it, it would be a right-tailed test. So that's kind of interesting depending on how you define things. But yes, either of those answers would be correct. But just don't mix up your P's and Q's. Once you pick one, stick with it. But yeah, I'd go with either one of those would be correct. Okay. All right. I almost want to ask a poll question. How are you guys going to do it on the test? Good, bad, or okay? I can give you 3 options.
I have one more question. Will there ever be a situation like this example that you've got right here, where we'll need to know how to calculate the standard, the sampling distribution, as far as like, in order to get S? Because you can do that, right, by taking the P times P minus 1, or the square root of P times P minus 1 over N, right? To get just your S.
I guess that would consider be S. Yeah, I mean, you're going to use the same standard deviation whether you're using P or Q.
Okay.
It's just one's going to be a left-tailed test, one's going to be a right-tailed test. That's the main difference.
And if it was a right-tailed test, you'd need to subtract whatever your P-score is from. After you obtain the Z-score, you'd need to subtract it from 1, correct?
Correct. Okay.
I think I got this.
All right. Okay, this is a good one. No, I want to pick another one. Let's do this one here. This looks like a good one. Hopefully I can do this one. Plus it's short. All right, research firm has been hired to determine the validity of age discrimination made against large multinational corporation. They decide that the best way to do this is to randomly select employees and find their age. The research firm has access to data that include the mean of the workers in similar companies as 42.7 years. They have no idea of knowing the standard deviation. They just randomly sample 170 employees and find the mean age is 39.9, standard deviation of 6.9. If they want to test the age discrimination, which hypothesis test should they use? This is a good one.
So wouldn't your mu be 42.7?
So you asked me a question, but I'm the one asking the questions.
Can I ask it like a Jeopardy question?
Yeah, this
What
is not
is mu?
Jeopardy.
X bar would be 39.9.
S would be equal to 6.9.
Did you say S or X?
S.
S is in
Sample
Sam?
Yeah, sample standard deviation.
S equals 6.9.
And N could be 170.
There actually is enough information in this one to answer it, but we won't do it. We'll just do the same thing we've been doing. All right, I think we got it all. That looks pretty good. Are you guys feeling pretty confident? Here, I'm going to ask this one to Janie. Janie, do you feel confident in picking out these numbers?
Yes.
How confident?
89%.
89%. I love the specificity. All right. Is it categorical or quantitative?
It's quantitative.
Quantitative. Do you guys all agree with that? Nobody shouting disagreement.
Yes.
Must be correct. Okay. Which equation or test should you use?
Z-test.
Say it again.
C.
A Z-test?
No, C.
A T-test?
Yes.
T-test 14. Okay, we're going to ask if everybody agrees or disagrees on this one. Agree and disagree. Oh, we're, let's see who hasn't voted yet. Easton, Janie, Seth and Les disagree. Elise picked the T. Are we to assume that Elise is going to agree or disagree with herself? Elise agrees with herself. Okay. So Seth, why do you disagree?
I thought if we knew the standard deviation, or is that just for sigma that we? Okay, I think I understand. Sorry, I'm trying to think. If we know the standard deviation, don't we say it's a z-test?
Well, it depends on which standard deviation we know.
So if it's the sample standard deviation, would it be a t-test then? Because sigma is for a population.
I'll be the one asking questions here. So are you changing your answer to a t-test?
If my question was right, then probably.
What about you, Wes?
Yes, I want to bail.
You want to bail? So
Yeah.
you're changing it to, so you thought it was a Z originally and now you think it's a T?
Yeah, because it's the sample standard, not the
It's a
population.
sample standard deviation. We know the sample, and so therefore it's t-test. Okay, so most of you got it right. Okay, so Yes, it should be a t-test mean. So well done. The majority of you did that. So what's the null and the alternative hypothesis?
Mu equals to 42.7. And mu is not equal to 22.7. 42.7.
Now, so that was the safe answer, I guess, because if you're not sure, now my question is to you, what is age discrimination? Does that mean to discriminate against old people or young people? So I'm going to ask this question because I want to see what you say, because people usually get it wrong, I've discovered. Do we discriminate against old or do we discriminate against young?
Can you go back to the question so we can see it again?
Well, so no, you don't need to look at the question for this. I just want to know if age discrimination. That was funny, Wes. Is age discrimination, is it discriminating against old people or is it discriminating against young people? Typically. Okay. Does everybody vote? 2 and 4, 6. Yes, it looks like everybody had voted. So this is the first class that's gotten that right. Okay. So usually people are like, well, it could be they discriminate against young people, and I guess they could, but usually old people have higher insurance costs and they don't want to pay for them. And so, okay, so now as we go back to this, at least played it safe, and because if you don't know, then you always say it's a two-sided test. But if you're testing age discrimination, which should it be, a greater than or less than?
Is this for anybody?
Yes, for anybody.
Less than, because we want to find out if the ones at this firm are less than 42.7, if they're the
Right.
ones discriminating.
That's right. Okay. So this would be a left-tailed as opposed to a right-tailed test. Okay. All right. So we've got 13 more minutes. I think I was lucky that I picked one of every kind. Will
it be kind of easier to like pick them out on the test because you'll be giving us all of the information to solve the problem, or you're not giving us all of the information?
No, I will be giving you all the information. Okay. Now, by the way, let me throw this at you really quick. Apparently, I forgot to release the last, I just noticed it, the last review. And so here's what I did. I have all these old reviews. And so remember really quickly, we're covering 17, 20, 22. So that's review 4. But we're also covering 15 and 16, which also includes review 3. We won't worry about 12 because you've already been tested on 12. But did you guys look over these?
I did.
I did too, and I also noticed that your lecture notes for the last couple of chapters aren't in there either.
Oh. I forgot to do that. I can put those in. Of course, it won't do you any good now, but it'll help you for next week. Do you have any questions from, here, we'll pull this up. So here's what we can do. So 12 we can skip. So central limit theorem, law of large numbers. Do you guys have any questions about any of that?
So the quick thing about the like proportions and means, so the proportion is like the NPQ is greater than 10, and then the means is like N is greater than 30, right?
Oh, I can't.
Like the requirement.
Okay, so sample size requirements, you said proportions, NPQ must be greater than 10, and means, what did you say?
Is N is greater than 30, right?
It's greater than 30. Do you guys agree? We're going to put you on the pins and needles. You can just do a voice vote.
I think I agree, but there's one part in the homework on yesterday's where they were asking about failures. Does the number of successes and failures matter when you're doing some of this testing or sample size?
Well, when we're talking about successes and failures, is that a proportion or is that a mean?
That's a proportion.
Yeah. And so we've got successes and failures built in. So that's going to be a proportion test right there.
All right. And then also for the NPQ, is that one it's like categorical, and then like when you have the means, that's when it's quantitative?
Yes, proportions are always two categories. And oh, by the way, just so that Janie knows, when we do the chi-square test next week, it's going to be more than two categories. Well, it could be two, but typically you use it for more than two.
Is it too late to drop this class?
Say that again.
I said, is it too late to drop this class?
Is it too late to drop this class? I think it is, unless you withdraw from school. I think you can still withdraw.
Okay.
Okay. Any other questions?
So this isn't about the chapter 15 or 16, but I was wondering if you could quickly go over margin of errors and like because there's like a lot of different like things where I was saying like if the confidence level increases, the margin of error increases, or if like, but like there's kind of like a lot of things that they were saying about margin of errors. So I was kind of confused on like what's like the law when it comes to margin of errors.
What's the law? That's a good question. Okay, so good, really good question. So we'll ignore this for now. We'll just write on here. Okay, so two ways to think about it. When we're doing a proportion test, so I'm going to ignore your z. We've got a z sub alpha over 2. I'm just going to write that as z times the square root of PQ over n. And if you're doing a mean test, you're going to have your z and you're going to multiply it by the either s, well, here, I guess sigma, divided by the square root of n. And if you have, so this is a mean z, if we did the mean t, and I'm going to ignore the t sub alpha over 2 times s over the square root of n. Okay. So, so you'll notice that in every case, we're dividing it by the square root of n. Okay. And in every case, this s, or the sigma, or in this case, the PQ, is going to represent your standard deviation. Okay? So there's 3 things you can change. You can change the critical value, is either the z or the t-score. You can change the standard deviation, and you can change the n. Okay. So as we think about this, if we change the critical value, what happens to this overall value? Does it get bigger or smaller in all three cases? So the critical value meaning the z or the t-score. So here, let's do it this way. If the critical value is bigger, then the margin of error goes, and then I'll just say up or down.
Up.
It's going to go up. Okay. All right. Now, in this case, if the standard deviation is bigger, so we're holding our critical value the same now, then here, I'm just going to copy this. Then the margin of error goes up or down.
Up.
That's also going to go up, right? If your n is bigger, then margin of error goes up or down.
Goes down.
It's going to go down. Okay, because the bigger your denominator is, the smaller this becomes, right? So when you look at just these, remember these are I didn't write out the alpha over 2, but those are your critical values. So does that make sense?
Yes, that's very helpful. Thank you.
That was a really good question, especially 4 minutes before the test. Okay. All right. Any other questions you guys have?
Allie, we can't hear you.
Is somebody
Yeah, right.
talking?
Sorry. Yeah, so from the p-value, just like double checking that this is right. So you go to whatever z-score you find, and then depending if it's a left score, then you don't subtract it from 1. But if you're looking for like the right tail, then you subtract it from 1, and that will be the p-value every single time, right?
So what you said was right, except for the every single time.
Okay, what that's like, what's the difference?
What
like
there's so you were correct. If it's left-tailed, you just take the value. If it's right-tailed, you subtract it from 1. We're only talking about z's, right?
Is it different with like the other ones, or
With the t, it's different.
all right, can you go over that really quickly?
Okay, very quickly because we've only got 2 minutes left. So remember, as we look at the t here, I'm going to pull out this up here. Hopefully I've got it right here. So remember, with your t-score, okay, you're going to get a t value. So let's say, since it's right there, that I had 19 degrees of freedom, and let's say I have a t-score of negative 2.1. It's the p-value in this case. Sorry, we're going to keep it on that line, so hopefully I can help you.
So when it comes to t-scores, like being negative doesn't matter, right? Like it's kind of like a positive.
You can kind of ignore it, but
okay.
it does matter. You can't. So if the correct answer was supposed to be negative 2.1, I better get negative 2.1 and not positive 2.1.
Okay. See, this is,
But what-
I was kind of confused on this, on the homework, so.
Because we're only going to be using the chart. We're not going to be using any technology on the T's. So what would be the correct p-value in this case?
Isn't it dependent on whether or not it's a right-tailed or left-tailed?
Okay, so with a t-score of negative 2.1, would it be right-tailed or left-tailed?
It would be left-tailed
Correct. Why?
because it's a negative number.
Because it's a negative number. Okay, so this is a left-tailed test. What's the p-value?
Isn't it 0.975 or 9? Or is it still just the 0.025? No, I'm confused.
Okay, we're out of time. So yeah, so you can see 2.1 is in between. Ooh, I didn't mean to. It's in between those two numbers, right? If we go back to here. So on the test, you should say that your p-value is in between 0.02 less than p-value less than 0.025.
So you would never have.
So in this case, you can't actually get the exact p-value. On the z-score, you can. If I got a z-score of negative 2.1, you would just pick that number. It would be 0.0179. But on the t-score, you would just have to say it's in between 0.02 and 0.025. If your alpha was 0.05, what would you reject or not reject?
You would reject.
You'd reject. Okay. All right. I'm taking up your time, so I'm going to stop there. But yeah, so your p-values, Ali, just to make sure you've got it since you asked the question, your p-value is always going to be in between. Actually, let me do one more. If I had a value of t equals 4, what would you say? Same 19 degrees of freedom.
Well, there isn't a 4 on the chart. So,
Right.
Is that where it's like p is less than 0.001 because it's not on the chart? Or is that only with the z-scores?
Well, we've got this right here. So yeah, so p-value would be less than 0.0005.
Oh, because that's the
Just
lowest.
off the chart.
Okay.
Yeah.
Got it.
What if I got so one more really quick here. We're still using 19 degrees of freedom. T equals negative 0.5.
So it'd be t is greater than 0.25 in that
Yes,
case?
P is greater than 0.25. That's the best you could do.
Okay.
Okay, because that's also off the chart off the other end.
Okay, got it. That's helpful. Thank you.
So in this case, if your alpha is 0.05, this would be a do not reject. And in this case, it would also be a reject, right?
Okay.
Okay. So you can't get exact p-values on the t-chart. You can only get those on the normal distribution. Normal distribution, you should round it to 4 decimals. T, you're going to have to tell me either it's in between a couple of numbers or it's greater than a number or greater than 0.25 because that's all we have, or less than that.
Okay.
Okay. All right. Well, I'm taking up all your time, so I'm going to let you guys go. So we'll stop the recording, and you guys are all going to ace my test. I know it's hard, but you'll ace it, right? Okay. Have fun.